Okay, so in short, I will try to explain, but this one is straightforward and is a bit easy. And this topic will be covered for, I think, class test 2 with numerical integration and differentiation, anything. Anyway, and this will be also covered in your project that I will disclose maybe next week, 5th week or 6th week, okay? And I will give you enough time, no problem. You need to write the codes for your project. Okay, anyway, so as you can see here, we are trying to do the curve fitting and do the interpolation. So this in my video I already explained that. For example, you have lots of experiment data, and you want to know the trend of the data, so you must do the curve fitting. So the curve fitting is our daily work when you are doing some research or from the data. So we need to know the trend of the data. We need to decide something. Not only that, we can also use this equation of the curve to get the any value that is unknown. For an example, you want to know the value of this y, the vertical line for this x is equal to some value. Then you can use this equation. Just put the value of x in the equation, you will get the y. So that x value should be in between the given range of the data. So we call this interpolation. If you're expected, you want to get something out of your box, that is extrapolation. So for an example, what I want to say that if your data is within the range of x1 and x2, you want to get x in between these two, this is interpolation. If you want to get the x outside of this x1 and x2, that is extrapolation. So this topic is not considering the extrapolation. So extrapolation, we have different algorithm to work. You can use the values, but you will not get the, you can use this technique for extrapolation, but I don't think you will get the accurate value, or you might get the value which has a big error. Anyway, so we have the two different types of thing. One is curve fitting, another one is least square regression. So how these tools are different? In my video, I already mentioned that. For an example, in short, okay, if you have two datas, you can make one straight line. Fitted curve. Curve fitting means, in this case, that polynomial curve fit. In this case, it means that the equation will satisfy the points. It means if you, after getting the equation, if you put the value of x, you will get y. And also for this different data points. So it means that your equation will satisfy the points 100%. Okay, or you have to use the strategy to satisfy this curve for any given amount of points. So also what is the number of points and what is the order of polynomial. So the thing is, if you have 2 points, maximum you can get first order polynomial. First order means a straight line. If you have 3 points, okay, then you can get at maximum second order polynomial. So it means the order is actually should be n minus the number of points. I mean the points should be always one bigger than the number of order. So if you have similar way, if you have a fourth point or 4 points, so you can, what are the options you can have? You can have first order, second order, and third order polynomial. So which one will give you better result? This is basic thing. Third order polynomial will give you the best result. Okay. And when we create these points, we will try to pass the points, pass the curve through each points. That is our main strategy. That we call this curve fitting. We fit the curve so that the curve passes through the points. That's how we define the coefficients. So coefficients will be like a0 plus a1x, right? Plus a2 x square plus a3 x cubed. This is the polynomial, normal polynomials. So you have to find out the value of a0, a1, a2, a3. So for this is the third order polynomial. If you want to consider up to second order, so your equation will be a0 plus a1x plus a2x squared, something like that. Okay. So however, why we need the least square techniques? So in case of polynomial fit, we have different strategies. Direct fit, that we satisfy the equation with the points. We have the Lagrange polynomial. We use the special types of polynomial, not like this a naught and not like this, okay? And we have the divided difference polynomial. We use the different techniques. We prepare a table, and from the table we can create the polynomials. So these are based on the curve fitting. On the other hand, why we have this statistical regression? Regression is the statistics term. So for an example, you have thousands of data. This one I already explained in my video. So it doesn't mean that you will use 999th order. Of course not. So we will try to get the line that fitted the curve best way. So in those cases, when your number of samples are too big, so what we try to find out, we try to find the summation of the error square is minimum. Okay, we try to consider the error for each points from your assumed calculation, and then we try to use the calculate the error for each sample point, square it, and then make it minimum. How we make it minimum? By differentiating with this the equations with respect to different coefficients. Okay, so that's how these polynomial and regression scale. The regressions are different. So regression, in case of regression, our main strategy is not to fit the curve. We try to minimize the square of the error. Okay. On the other hand, for curve fitting, we try to fit the curve that passes through the given sample points. Okay, so these things I already explained. Okay. For example, in case of Lagrange polynomial, just hold on. Okay, these things, as I said, I already explained, and just to give you the sense, and by other things you can solve it by yourself. Okay, it's not that much like some particular method that we use here to solve. So we just need to remember the form equations, and then we do just substitution. Okay, we just do the substitution, and we need to remember the equations, or we need to remember the logics. Hold on, something wrong here. And okay. Okay, this one I already explained in the videos. Okay, so I try to go to the Lagrange polynomial. So in case of Lagrange interpolation or Lagrange polynomial, whatever it says, the equation is like this. Okay, so the equation, the polynomial equation will be a naught x minus x1 x minus x2. Okay, and then a1 x minus x naught x minus x2, and a2 x minus x naught x minus x1. So I expect you all watch my video, then whatever I say, you will understand. Okay, otherwise you will see what I'm saying, you will not get those points. So there is some logic, right? We start for a naught, a1, and a2, and we start with x minus x naught. We cannot do that, so we just use the x minus x1 x minus x2. Similar way for a1, we can use x minus x naught x minus x2, but just we left the one term x minus x1 we cannot write. For a2 same, we cannot write x minus x2. So after that, because the Lagrange polynomial or divided difference method or quadratic polynomial all are based on curve fit, so we need to satisfy the curve with the given points. So the Lagrange polynomial is first order. We have the second order, third order, fourth order. So in this case, this is a second order polynomial. If you have third order, so please watch my video how you can modify the equations. Okay. So in case of third order, we will have x. I just explained this one: a naught x minus x1 x minus x2 x minus x3. If you have fourth order, then maybe you have extra x minus x4. So if the number of orders, if it is 2, you will have 2 terms. If you have 4, if you will have 4 terms. But normally, basically, we use second order or third order. Then we satisfy the equation. It means this equation must satisfy x0 y0 point, x1 y1 point, x2 y2 point, x3 y3 points. So then satisfy equation, we have three unknowns, so you have three equations, and then just shift this one and you will get a0, a1 and a2. Okay, so what you can do is, in my video I said that you can calculate the value of a0, a1 and a2 and then substitute this one in the main equation. Then you will get the equation already, polynomial equations. Or if you want the shortcut, or if you want to do it all together, then you can use this equation directly. Okay, so I'll go to the main point here. Or not this one. So here you can see that they use the same thing strategy. It means they use the equation directly, but you can use it, or you cannot use it. Just calculate the coefficient separately and then put it the main equation. That should be also okay. It's up to you. So you will get these kinds of polynomial. Just or you, as I said, this chapter is actually just to remember the equations and substitute the values. So you know that A, B, C. If you just substitute the values and just simplify it, then you will get the polynomial equation. The main objective is to get the polynomial equations. So this one is a Lagrange polynomial. If you use this formula or this strategy, so these things I already described. Okay, I don't want to go again. And then we have the divided difference technique. That is another form of curve-fitted polynomial. In that case, we need to create the table. Okay, and if we create the table, the polynomial, first of all, you need to know the polynomials. So how you can get the polynomials here? So polynomial, again, in this case, we have a special type of polynomial, and it can be written in this way. I don't know why the PC is slow. Just hold on. Okay, so this is the expression. Okay, a0, a1, x minus x0. It's a little bit different than the Lagrange polynomials. We call this Newton divided difference method or divided difference polynomial or Newton's polynomial. Okay, so a0, a1, x minus x0, a0, a2, then x minus x0, x minus x1. So how we can get the a1, a0, a1, and a2? These things we can get from the tables. And how we can create the tables? To create the table, this one also I explained. I don't know why it's slow. It's hanging each time. Okay, just wait. Okay, when we create the table, this coefficient here is totally making problems. Okay. So the coefficient, after you make the table, I will again briefly explain how you can make the table, divided difference table. Then the value, the coefficients a0 is actually f of x0, and a1 will be f of x0, x1, and a2 will be f of x0, x1, x2. Because these are notations, okay? It means these are all the values you will get. After making the table, these are actually values. After you got the values, the first value is a0, this one a1, a2, a3. You need to consider the first element of each column that will represent your coefficients in the polynomial. Which polynomial? The polynomial that is given by this one, a0, a1, a2, something like that, okay? So if you put the value of a0, a1, and a2, you will get the results. So I can show you the simple example of this. This one I better stop here. Okay, so they create the table here. In this case, okay, when you make the table, this one I already mentioned in my video. This actually f of x naught. You can write in this way. Instead of writing this one, you can write f of x naught x1. You can write here f of x naught x1, x naught x1 and x2. So if you have this table, make this table ready, and then you just put the value of x, okay, and just put the value of y. These values will be given. So x naught, y naught, these values will be given, x1, y1, and in this case x2, y2. So they are considering you to make the second order polynomial. So these are the x value and y value. So this already given to you, this one and this one. Then how you get the values of this? In order to get this value, we call this divided difference. So divided difference means we consider the difference and we divide it. So mainly we have dy dx. This is the form, okay? So we need to make that divided. It means we will have y1, yi minus something, okay? I will not write it which value. It means we need to consider the y difference divided by x difference. Maybe xi minus xj, yi minus yj, okay, whatever it is. So we need to consider this one. So this value can be got like is equal to, when we focus on the divided difference method, so when we consider the upper part, the y value, always consider the next column values, okay? So in this case, your difference in the y will be y1 minus y2. I mean this minus this. I'm just not like pronouncing y1, y2, y3. So you just consider this minus this. Okay, and write the value divided by. Now you need to think, when you divide it, which one you divide. So you have to go to the column heading. In the column heading, we have x naught and x1. You see the difference here, 0 and 1. So 1 minus 0 is 1. So the difference, when you consider the difference should be minimum 1. So what does it mean if you're confused? It means you focus here, 1. So you start with 1. So 1 means here, right? This one is x naught, this one x1, this one x2. I mean the value. So that should be x1. You start first value will be x1 minus x0. It means this minus this. Remember, this minus this. So your first element will be, in this case, y1 minus y0 divided by x1 minus x0. If you do that, you will get this. It means this minus this divided by 3.5 minus 3.4. You will get these values. Okay. So how about this one? This one will be, again, as I said, when you need to calculate these values, so you have to focus here which part. The first, the adjacent column. So it means this one. This will be, again, we will do the same thing. This minus this. So just write it down. That should be y2 minus y1 and divided by, now again you need to think. So before you got 1, 0. Now you will have what? You need to consider 2, 1. So 3.6 minus 3.5. Okay. So remember that 1 x1 minus x0, x2 minus x1. So the difference is actually always 1. 0 minus 1 is 1. 2 minus 1 is 1. Okay, clear? So if it is okay, then can you do the next one? No, we don't have. So remember that when we do the Newton's divided difference method, so the element, first we have 3, value of y is 3. After this next column, we will have only 2. It will reduce by 1. And we normally consider the difference in between this one, just to make you understand, okay? If you don't want, you can also create the first and second element. No need to write like this. But this is a good way to make sure like you will gradually sum up, okay? It means gradually reduce to the one element. Okay, so next one is this one, right? Where we have the heading is actually, you can write this one, or I prefer you to write this one. Okay, so I ask you to write this one maybe. So we have the f, x0, x1, and x2, 3 terms. So when you consider again this term, how we can get this value? This one, when you consider the upper part, y is the same. This minus this, lower minus upper. You always do the same thing, okay? Lower minus upper. So in this case, that value will be lower minus. I cannot write this one is y. So lower minus upper, just write these two values divided by what you will write. In this case, your first element is x0, your last element is x2. So your divided by last minus first, it means x2 minus x0. Sorry, where it goes. So it should be x2 minus x0. Okay, so that will be your 3.6 minus 3.4. That's important. Okay, so if you have next one, that should be starting point will be 3 minus 0. So now we don't have the additional term here because it already end, but sometimes we might have additional term. So if your for this element your division is x2 minus x0, for the next element, if you would have another element, so you will do again the same thing for the y. It means the lower minus the lower minus upper value divided by what would be the value for this, the next element, if you would have. Now you don't have here. Okay, so for an example, if you have another element here, you need to write it down. So what would be the value? That should be 2 will become 3 and 1 will be 0 will become 1. Remember that one. Okay, just follow up like this. So if you can start this correctly, and that depends on this function, last minus first, then you will have the same thing, just increase the 1 by 1. Okay, so if you can remember this one, you can prepare the table, and after you finish the table, now you cannot continue. For an example, so your a0 will be this one will be a1, this one will be a2. Put the value in the polynomial, you will get the answers. So we call this divided difference polynomial. Okay, so the Lagrange polynomial and divided difference polynomial, these are important. So in the book, okay, when you will see the video, or if you already saw the video, I will open the book now. Okay, so if you see the problem in the books, so we have the least square regression. So they start with the linear problem, they call this a regression. They start with the regression. Okay, so I start my lecture with what can I say, the curve fitting. So it's different. So this is the interpolation part for the book. So this one I already explained from in my video, linear interpolation. Then we have the quadratic interpolation. This one quadratic interpolation, and when I explained in my video, my quadratic interpolation was actually different. So quadratic interpolation, we call this one ax square plus bx plus c. Then we satisfy the equation. We get the system of linear equation. We got the value of a0, a1, and a2, and we substitute the values. So linear and quadratic equation is straightforward. How we solve the problems. Lagrange interpolation, we need to use the Lagrange form of polynomial. For Newton divided difference equation, polynomial, we need to use his proposed way of polynomial equation, and then we need to find out the coefficient using the formulas. In case of divided difference method, we need to use the table. In case of Lagrange polynomial, we use the same technique, satisfying the equation with the points, but we have the different types of polynomial. It's not like these types of polynomial. Okay, those things are different. But I don't know why they put in the quadratic interpolation in the book. They put in this one is actually they use the formula for Newton's method. I mean the divided difference method. But I don't agree with this. Okay. So if you are writing the quadratic interpolation, that should be this one, not this one. But that's why I have doubt. Anyway, if they say that quadratic interpolation, most probably we rarely give this one, but because it's this in the book, you just follow this technique. But I don't agree with this. Okay, but if they put the questions like from here and all the answer stream from here, so we need to follow that one. So this is actually quadratic interpolation, okay? But instead of considering a0, a1x plus a2x squared, they consider the polynomial that is equal or equivalent to the divided difference polynomial. Okay? But they are not considering it as a Newton's divided difference method because they are not preparing the table. They are calculating the value of a0, b0, b1, and b2 by using these expressions. Okay, this is actually same. Okay, that's actually same. It means if you prepare the table, we do automatically this type of calculation from these equations. Okay, so you can see they also use the divided difference to make the difference and divide it by the corresponding values. Okay, so in short, like if I want to summarize the things, if they say the quadratic interpolation, we stick on this in this topic. Okay, I mean in this polynomial, and then use the coefficients using the form of equation, not from the table. Okay. So in this case, you have to remember b0 should be x0, f of x0. Actually, b0 is actually y. Okay, y0, and b1 it will be y1 minus y2. Y1 minus y0, x1 minus x0. For b2, as I said before, last minus first, it means 2 minus 0. 2 minus 0, and then it will be 2 minus 1, 1 minus 0. Okay, so just consider up to b2. So if they consider b3, they will not consider because it's a quadratic, so second order polynomial, that should be okay. So find a quadratic equation, this one that goes through the 3 points. Okay, so if they say this one, you can just use the satisfy the equations, you will get the polynomial, same polynomial. But if they ask you to use this polynomial for your quadratic interpolation, then you have to use these equations. Okay, just spend some time, you will get the relationships and just try to remember. So as I say, basically the equation should be like this, and then we just satisfy the equation as usual. But if they focus on you have to use this polynomial, then just use the value of b0, b1, and b2 as explained here, and substitute the value of y and b2, all the values, and then you can get the value b0, b1, and b2 and substitute it. Straightforward. So this chapter is actually just substituting the values, getting the coefficients, put it in the main polynomial equations, in short. Okay. So these things like quadratic interpolation, yeah. So sometimes they ask you to calculate the values and then also estimate, compare it with the this one. I mean, to estimate the value of this one at x is equal to 1. Okay, so you have to find out the value of it. You have to do the interpolation, in short. So the value of x0, x1, x2 given, but y is not given. Y, instead of giving the y, they give you the equation or the functions. Okay, so you have to decide. I mean, you have to understand the things. Sometimes the values of x and y, these are not always given. Sometimes the value of x are given. Y could be given directly. Y could be given in some equation form. Y could be given in terms of function form. Okay, so just substitute the value of x0 0, then you will get the y0. If you put the value of x1, you will get y1. If you put the value of x2 in the equation, you will get y2. So you already have the ready 3 points, then you start your calculation. So which method they say? Develop a quadratic interpolation. So as I said before, they use this one, the Newton's form of equation, but instead of using the table, you use this one. I mean the formula directly. And sometimes they use the f2x, sometimes they use the p2x. P2x means polynomial, second order polynomial. 2 means that's order, okay, second order. Because it's a quadratic means second order. The Newton's polynomial, Newton's divided difference method. So as I said, already explained this one. So no need to go in details here. Just learn whatever I said, like prepare the table, go to the solution directly. Don't waste the time, okay? So if you really want to understand, you can go to the in-depth of those things. But for this, I think at this stage, maybe you just understand how we solve the problems and how we get the coefficients and how we can also get the error. Okay, sometimes the values, exact value, you already know the value of the equation is given, it means you know the exact value. So prepare, calculate this value, and from the exact solution, if you put the e to the power 0.6, 0.5 in the calculator, you will get this one. That is the true value or exact value. And from the divided difference method, if you get the polynomial, put the value of x1 in the polynomial, you will get the expected value or calculated value. Then you can calculate the error. Okay, you need to calculate the error. Okay, as I said, the values of x and y, so 6 points are given in this case. These are already explained, okay? So these are x, y, 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 x1, y1, x2, y2. So all the points are given. They ask you to prepare the quadratic Newton's divide and difference formula. Quadratic means second order. They use the Newton's divide difference formula. Okay, now you use the table here and get the values directly from there. Instead of writing this one, you just write x0, x1, and x0, x1, x2. The way I explain, you follow that way. Otherwise, the ij, you can follow it. If you can understand, it should be okay. But if I go to in that way of explaining, maybe you might be confused. So that's why I just make it 0, 1, 0, 1, 2, 0, 1, 2, 3, something like that. And after preparing the table, you can follow my lectures. I already explained a little bit in depth about the table. And then you can get the values, coefficients from the table, the first element of each column, and then substitute in the main equation. That means B0, B1, and B2, you will get the values. And of course, when you substitute the B0, B1, and B2, you already know the X0, you already know the X1. So you have to do the substitutions, okay? And you can keep the equation in this form, should be okay. And sometimes you can also split it, okay? Ax square plus bx by bx plus c form, that's also okay, no problem. If you don't have time, just substitute the value and just write the equations. And if you put the value of x is equal to 2.5, you will get the equation. I mean, you get the answers. Sometimes you have to compare the value with the given value or from the true values. Lagrange polynomial, I already explained, okay? So these are very, very simple things. You just go through the problems. Okay, so they consider the linear interpolation, quadratic interpolation. So we have the errors, of course. For quadratic interpolation, we will have less errors. Sometimes I will ask you why there is a less error in quadratic interpolation, or which one is better, which one you prefer. There are some computer programs that you can have a look when you will go through the problems in the project. Okay, there are some simple problems. You can also solve those things. Okay, the thing is, now I will explain about the regression. Okay, so regression is, as I said, we need to minimize the square of the error. So we call this least square technique. Least means minimum, square is in this case, square means the error square. And the technique is the regressions, okay? So in short, so I don't want to go in details. So just for an example, if you consider the line method means that we will consider the first order polynomial a0, a1x. For example, the actual value is yi, and this is the expected value. Put the value of function, that is your polynomial equation. So you have to minimize this one, and we minimize this with respect to, we consider the derivative of this error with respect to a1 and a2, a0. Then you have two equations, and solve the two equations to get a0 and a1. Okay, in short is like that. If you have three equations, I mean the a0, a1, and a2, you need to differentiate this one error with respect to a0, a1, and a2. You will get three equations. System of equations, of course, system of linear equation you will get. You can use Gauss elimination, Gauss-Jordan elimination, whatever method you prefer, you can use. We already know how to solve the system of linear equations. Then you can get the coefficients and substitute, you will get the polynomials. So in short, if I go here, in my video I showed these things, okay? This is the form of equation. If you can remember this one, I mean, this is third order. If you have two orders, so just consider 2 by 2 matrix. If you have 4 order, you can increase this one, okay? So this should be the form, n summation of xi, summation of xi square, summation of x, summation of x square, x cube, is square. X is increasing gradually, right? This one is only y, then xy, x square y, then x cube y, if you have that one. The fourth order equation. Normally we consider 3 by 3 matrix. So if you know this form of equations, so this is the equation that you have to solve when you use the least square technique. So you have to find out the value of n means number of points, summation of x, whatever value the x are given, just you need to sum up. X square, square it and sum up, cube it and sum up to the power 4 and sum up y sum up, then xy product sum up is square y sum up. So if you have all the values, substitute this value, you will get three equations, right? Or just you have the matrix ready made. So just start the Gauss elimination and Gauss-Jordan elimination. You will get the value of A0, A1, A2 directly if you use the Gauss-Jordan elimination. Or if you use backward substitution, that is Gauss elimination, then you have to use the substitution method, right? You will get A0 first, A2 first, then A1, and then A0. As simple as this, okay? And another one is multiphase. Multiphase, what is multiphase? Multiphase is, in this case, you will have two independent variable. Okay, in this case, x is dependent on y, but sometimes we have x depends on y and z. It's like something like that. So the equations could be a plus bx plus cy, because z depends on x and y. And in that case, same thing, we will do the same thing, and we will differentiate with respect to a, b, and c. If you sum up, you will have this one. This is the matrix for the multiphase, multi-regression. So x to the power 0 is actually 1, okay? The summation of z is equal to a, x to the power 0 is 1, this is actually n, a n plus b summation of x plus c summation of y. This one should be summation of x I z I. So you understand what I say. So you can replicate or recreate this matrix here for multiphase when the x depends on y and z. So similar way, just solve the problems. Okay. So these are the things. For regression, you need to use multiphase, single phase. And single phase, we have line method. I mean the linear interpolation regression. Sometimes we have the multiple or second order interpolation regression analysis. We can consider third order. It depends. We have the matrix and solve the matrix using Gauss elimination or Gauss-Jordan elimination. You can also use the iteration technique. It's up to you. And on the other hand, we have direct method, quadratic interpolation, Lagrange polynomial, and we have Newton's divided difference method, where we need to create the tables. So I just give you the rough ideas, okay? And if I go to the problem in the book, I go to the regression. So regression is a straightforward polynomial curve fit, okay? Yes. Okay, in this case, okay, start here, right? So this is the formula, okay? This is the second order because it depends on the y only. Linear regression, sorry, this is the first order. So you will have only 2 by 2 matrix. Use the matrix that I said in the slides, make it 2 by 2, and then get the values and substitute this one and solve the problems. In this case, they consider the linear regression following points. We have 5 points. You can see summation of x, summation of y, summation of x square, summation of xy. Then if you put these values in the table is not mentioned, table is mentioned in the here. I hope you understand. Where is that? This one. So if you put these values, now we are considering linear regression. So this 2 by 2 matrix, you will have n, x, and then x square, you have y and xy. Put the values, get the matrix, and then solve it. You will get a0 and a1. Put the value in the equation, you will get the solutions. So we have polynomial curve fitting, then we have multiples. Okay, so it depends on which order they say. The velocity is measured, it means the value of x and y, these are given. They ask you to consider second order polynomial. Okay, so you use the second order, you must have three points, that is, you have to consider x, y, I mean the 3 by 3 matrix. So in this case, we are considering regression, so we consider all the points, okay, and try to minimize the error. That is the basic things. Here you can see it's a multi-phase problem. This one I already explained in my video. We don't have enough time. So here the diameter d depends on, sorry, not diameter, the flow. Flow depends on the diameter and slope. So it's 2 independent variables, 1 dependent variable. So this is a multi-phase problem. So this one I already explained is important. You might have these kinds of multi-phase, 2-phase, 3-phases problem. And we have the relationship already given. Q is equal to A0 d to the power A1 and S to the power A2. So you have to find out A0, A1, and A2. Then we simplify it, and I already explained how we can simplify it. And in this case, we use the multi-regression formula. It means we have to use not this one. We have to use the multi-regression. It means this equation. Okay, this is the depends on x, y, and z. In this case, x is actually q, y is actually d, and z is actually s. Okay. This one I already explained in my videos. If you have a look, other things are what that's okay. I think these are the very simple things that you can solve. Mainly, you need to know the Lagrange polynomials. So what I can do, I can, because we have 10 minutes. So let's try to solve this problem. Okay, multi-phase. You might not get this kinds of problem in the class test, but we can solve it. Okay, because we have 10 minutes. So start solve this one. Everyone okay? Are you okay?
You three.
Super.
Okay, so what we'll do, I think just for today, I will put a partition so that it's easier for us to put things inside.
So here you
encroach on other people's columns.
So this one, what we do here, we try to solve this problem. Okay, we try to find out the value of A1, A0, A1, and A2. So we have the equations. So try to solve the equation, write it down. Q is equal to is approximately equal to A0, then dA to the power A1 and S to the power A2. Then make the logarithm. I mean, put the ln together. We need to make it a linear equations. I mean, expand it. Okay, do it. Take log the both side. Then what we can write? So we have Q, then A naught is actually approximate, okay? D A1, S A2. We might have these kinds of relationship also, okay? Could be like this only. Maybe it's not here. Then it's single phase, but you have to linearize it. How we will linearize? We take the ln, and then solve it. We will get what? Ln A naught plus A1 ln D, and then A2 ln S. Is it right? So here now, if you compare this one, okay. So how you compare y is equal to? I consider A naught because we also have A naught actually. What we can do? Okay, I put A star because we already have A naught. Then plus we can consider A1. We have A1. This one y. Okay. Maybe x. Y depends on x and z. Or what we can do? Okay. Or I can say that x depends on y and z. Should be okay. No problem. So y. This should be then y. Okay. And then A to z. So you have to mention that in this case your x is actually ln q. Okay. And your A star is actually nothing but ln A naught, and we have y is actually ln d, and z in this case is ln s. Now you apply the formula. So if you have x depends on y and z, what would be the solution? So in this case we have the A star, A1, A2, and you need to find the matrix. Do it. How to do? So we have how many dependents? So write down the matrix first. So that matrix should be so summation of what? This is the follow this one. Summation of zi. So this one, make sure the formation is in this case is same. Okay, so let's see. which one is x, which one is z. Oh, so you have to represent in this way. Okay, if you follow the process, z should be depends on x and y. So in my explanation, so if you want to compare, that should be actually z. Okay, I correct it. Z should be, this one should be x, and this one should be y. That's okay, just a notation. But if you are following that slide, I mean, you just want summation of zi, then this should be zi. Okay, otherwise you will be in trouble. So in this case, I just need to route these things. This one should be z, this one should be x, this one should be y. Now is it okay? Z is equal to a0 a1 y plus a2 z. We don't have enough time, so yeah, ABC or a1 a2 a3, whatever it is, it should be okay. Then that should be summation of zi is equal to, so just I put one thing, okay, summation of zi, this one I understand, a multiplied by n, then b summation of xi yi, this one xi zi x square xi yi, then yi zi yi xi yi, and then y square. Let's try to find out summation of zi, how you can calculate summation of zi for this part. So summation of zi means, what is z here? Is ln q, right? Ln q. So you have to find out the summation of ln q. So in this part, what is the summation of ln q? You go to the q. So you have to put ln 1.4 plus ln 1.8, 8.3. Can you sum up? Summation of zi means z is equal to ln of q. So summation of q is how much? How much is this? The first column, then sum, or no, I just ask you this one. You need to write the matrix, whole matrix, right? So in this matrix, we just calculate this one. I just to make you to give the sense how we can calculate. So in this case, the first element is this one, the right hand side actually is should be summation of x I to the power 0 means 1, then summation of zi. So this part is summation of zi, a multiplied by n. N is number of points, b multiplied by x, plus c multiplied by summation of y. You can write it down, okay? If it looks complicated, just write it down. So write the formula, and then after that, you put the values, okay? Sum up all the quantities that is mentioned, and you will get the matrix mainly. So in that matrix, I just want to find out what is the estimate of how much is this. So this one is summation of zi. So zi in our case is actually ln q. So it means summation of ln q. So all the q, you need to ln it and then sum up. That's why I say, because I don't have enough time to make all the things. Then after that, after I end the class, you can substitute all the values and get the solution. So I hope when you will get all the q, that q is actually here. Okay, I think it's 11.691. Oh, in the first one, sum of, oh, no, you have to ln first, ln q, summation of ln q. Okay, sorry, I misunderstood. So it means like you have to ln each element and then sum. Ln 1.4 plus ln 8.3 plus ln 424. Is it 26? 26. Why it's different? Okay, one more thing. Can you, this one is a number of element 9. This was n. And okay, can you calculate this one? Summation of xi. So this one an, this one is okay. If I compare with this one is 9 element. N means line. So I'm not sure they use the log or ln. It should be ln. Oh, I see. They use log. I think if you can consider the ln or log, it should be ln. I don't know. They use 10 base log. Log is two types, right? 10 base and e base. So I'm not sure which one but it should use e base log. Okay, anyway, just can you just quickly, I know the time is up. Can you quickly count this one? This one is log of 1 plus log of 2. It means log of d. Can you quickly count ln 1 plus ln 2 plus ln 3 plus ln 1 plus ln 2 plus ln 3 plus ln 1 plus ln 2 plus ln 3? How much is it? If it is not matching, then we can try with the log. But normally we use Napoleon logarithm. Can you try this one? 5.3. And then can you try log now? Log 10 base log. It's not matching. I think they consider log. Can you consider log and then try to match this value? Oh, they use log. Okay, can you do me one favor? You try to solve with the ln, okay? And try to get the value of a0, a1, and a2. Because, okay, if you use ln in this case, so you will use exponential, right? So ln a0 should be, so a0 will be e to the power something. Maybe they use the different strategies. Can you try to solve with log and ln? And what will be the result? The result should be same. Okay, so this is your task. Let me know in the WhatsApp group. So solve with the ln. Try to get the value of a0, a1, and a2. But normally we never use the log. I don't know why they use log. We use the ln and then split it. Okay. So please do me this favor. Let me know. So then I can rethink on that. Why they do like this log, and I'll try to explain it again. Okay, so that's the end of this today's class. So this week we will have the class test on eigenvalues. Okay, so I already took the class test, so it means you already studied those things. So it will give you the wait, I will give you that. It will give you opportunity when you will do the class test. Okay, so you already went through all the things. So this week the class test will be on eigenvalues. Okay, section 3. Yeah, section for both. Okay, I will open the attendance again.
Sir,
Yes, please.
in the invitation for the third video, I think you sent the wrong video.
Wrong.
Yeah, because that one is for vibration.
Oh. Okay. I will try to fix it up.
Okay.
Okay, sorry. Which section? Section 3 or 4 or both?
What is it, sir?
I mean, I uploaded the wrong video, right? You mean?
Yeah.
I mean, which section? 3. Section 3.
The wrong video, I am section 4.
Section 4. Okay, I'm sorry.
Okay.
Okay, I will fix it today. Well, maybe within 5 minutes I will fix. Okay, so we don't have enough time. Okay, section 3.